Hello, student. Hello, student. Am I audible? Hello. Hello, student. So, in the last lecture, we completed what is microwave, and from this lecture, advantages, disadvantages of microwave, and now we are going to start the microwave components. So, microwave circuit is first of all called as a hybrid circuit because some part of it is used as a electronics circuit, so it is a hybrid circuit and it consists several microwave devices. Okay, we want to the first parameter that we want to achieve a data transmission of microwave signal. In microwave components, the first and very important component is a T. So where we require T when we want to interconnect two or more microwave devices, then it is called as a microwave junction. What is a junction? In normal life, when we are called the junction is there. Junction is for the connection or connecting point for two, three ways. If we are traveling from Mumbai, Pune, or Nashik, then what is a junction point? It is a Nashik Fata or Wakad from junction for a Baner, then Pune and Mumbai. So this junction we require in networking, and that junction in a microwave, to create that junction or the junctions where we are connecting more than 2 points, it is called microwave or waveguide teeth. So waveguide teeth is nothing but a interconnection of two or more microwave devices. How many types of a teeth? E-plane T, H-plane T, magic T. Remaining components of microwave is a directional coupler, circulator and isolator. So we will start with a T. So this first diagram shows collinear arms of a E-plane T. So these are the collinear arms, port 1, port 3, and this is a E arm, this is a port 2. These collinear arms, port 1 and port 3 are interchangeable. Okay. Port 2, E arm is not interchangeable. So always remember that. Now this is H plane T. In the H plane T, this is H arm, then port 1, port 3. These are the collinear arms. Okay. This is the magic T. In the magic T, arm 1, 2, arm S and arm P. These are the magic T. And this is a hybrid ring. So in a hybrid ring, if you want to add paths, you can add here. Okay. Only the important is a distance between the two paths and this dimension. Okay. This is a directional coupler. In a directional coupler, one, two, three, four ports are there. Okay. And this is a circulator. So in a circulator, always remember that if you are going to apply input from port 2, then you are getting output at port 4. Means you have to you are not getting the input in a next port, and it is always in a clockwise direction. It is not in a anti-clockwise direction. Okay. So before starting the study of a component, first we have to understand how many network types. So network types, normal network types is a one port network, then two port network and multi-port network. These are the main three types of a network. If we want to analyze this network, then how many parameters we are having? So till this point we studied H, Y, Z and ABCD parameters. This is a two port network. In a two port network, we are going to assume that network is a black box. So we are not going to in detail that how what is components are there, resistor is there, capacitor is there, or what is the nature of this component, resistive, capacitive, or inductive. We are just going to assume that this is a black box, and that black box there are two terminals for input and two terminals for output. So it is a V1 voltage is going to get here plus minus, and this current is a I1. Similarly, at this port V2 voltage I am going to get plus minus, and current is a I2. So to analyze this network, we are having H, Y, Z and ABCD parameters. H means hybrid, Y means admittance, Z means impedance, and ABCD is for the transmission parameters. Okay. So these are the formulas that how we can find out H parameters. So H parameters is a hybrid. That's why voltage and current combination is there. Then H11, H12, H21, H22, I1 and V2. So this is a formula for V1. This is a formula for I2. Similarly, for admittance, admittance means current is equal to admittance into voltage. So this is a formula. Similarly, for I1, this formula is used, I2, this formula is used. Then third one is the Z parameters. So Z parameters is equal to voltage is equal to impedance into current. So V1 is equal to Z11 I1 plus Z12 I2. Okay. And last one is the ABCD parameter. So in a ABCD parameter, transmission line, so V1 I1 A B C D V2 and minus I2. Okay. Now the very important question is that can we use these parameters for microwave component analysis? This is very important question that we want answer, or we are going to try to find this answer. Okay. So when we want to find these parameters, these are related voltage, total voltages and total currents at each of the two ports. That is, for example, H11 is equal to V1 divided by I1. So V2 is equal to 0, and H12 is equal to V1 divided by V2. I1 is equal to 0. So first one, when we want to find H11, we are going to make short circuit, and when we want to find H12 we are using open circuit. Okay, so this is a very important condition for ABCD parameters, then Y, Z and then H. So if you remember the formulas, when we want to find those parameters H, Y, Z and ABCD, the necessary condition is that we want to short or open the circuit. Okay, but is it possible in a microwave? This procedure, when we can we short or can we open the microwave components and then we can do measurements, or the main question is if the frequencies are in microwave range, is it possible to short a circuit or open a circuit? Because microwave frequencies are dangerous, we can't send them directly in environment. Okay, so this is a very important answer, that we can't use H, Y, Z parameters for measurement of a microwave. And these are the reasoning. So first reason is that if you want to measure H, Y and Z parameters, then how many equipments we are using? Voltmeter, ammeter, okay? Those are easily available in your labs. But for microwave, when we want to use or we want to measure the voltage and current, the equipment is not available. Which equipment? Those can measure a total current at the ports of the network. Okay. Now the second point is short and open circuits. When we want to do open and short circuits in microwave, it is very difficult to achieve. Okay, So second question is, it is very difficult to open and short circuit microwave, okay, because it is difficult to achieve over a broad band of frequencies. The main problem is the frequency. Third point is active devices, means in a microwave we are using active devices such as power transistor, tunnel diodes, okay, or some klystron tubes, then gun diode. So for that active devices, they are not stable for a short or open circuit. Means their working is going to change when they are working in a short and open circuit. So the main problem is that we can't achieve the measurement for microwave components by using short circuit or open circuit, or in a concluded statement we can't use H, Y and Z parameters for microwave. So what is a new method, or now we require a new characterization. So the new parameters that we are going to use for a microwave is a S parameter or scattering parameters. Again I repeat, S parameter or scattering parameters. Now, what is actually happening in a microwave? In a microwave, the logical variables to be used at the microwave frequencies are traveling waves rather than total voltage and total currents. Please remember this. What is that? Microwave frequencies or traveling waves we have to consider. So for S parameter, the formula is B1 is equal to S11A1 plus S12A2, and second B2 is equal to S21A1 plus S22A2. So B1 is the output, A1 is the input, and S is a scattering parameter. This is your diagram. So similarly, this is a black box, S11, S12, S21, S22. Okay. This is your input impedance, this is output impedance. Now both are same because why both are same, Zg and Zg, because we want maximum power transfer, and for maximum power transfer theorem we already know that input impedance is equal to output impedance. So this is my B1, A1, A2 input, and this is my B2. Okay. Now these are the types of teas, all teas. Some H plane tea, E plane tea, magic tea, hybrid rings, corners, bend, twisters. From this, first, second, third is in our syllabus. H plenty, E plenty, and magic tea. Okay. So now we are going to start the study junctions or T's according to scattering parameters. So T junction, a waveguide or coaxial line junction with three independent ports. This is very important. Now, the we want to plot a matrix, because if you remember when we are studying the parameters, then it is very important that matrix for input and output. So for three ports, how many matrix is there? It is a three order because three ports contain nine elements, okay, and six of which should be independent because we want to write a equation, okay. So the characteristic of a three-port junction can be explained by three theorems of T-junction. These theorems are derived from the equivalent circuit representation of a T-junction. So what is the statement? A short circuit may always be placed in one of the arms of a three-port junction in such a way that no power can be transferred through the other two arms. This is very important. That means there should be no back reflection. Can we do a arrangement that there should be no black back reflection? Okay. And second, if the junction is symmetric about one of its arms, a short circuit can always be placed in that arm so that no reflection occur in power transmission between the two arms. Okay. So these are the two statements. If the junction is symmetric about one of its arm and the short circuit can always be placed in that arm so that no reflections occur in the power transmission. So it is very important that match impedance. If match impedance is there, then there is a no back reflection in a teeth. Okay. And third, it is impossible for a general three-port junction. It is impossible for a general three-port junction of arbitrary symmetry to present match impedance at all three arms. This is very important statement. That means you are not going to get a lossless matrix. In matrix, you always find some loss. Practically, ideally, we can get a lossless matrix or lossless component, but practically, we can't achieve this condition. So this is a E-plane T. These are the collinear arm and this is the E arm. So it is called series T. Please remember E plane T is called series T. Okay. A waveguide T in which the axis of a side arm is parallel to the E field of the main guide. It is a parallel to the E field. Okay. So if collinear arms are symmetric about the side arm, there are two different transmission characteristics. Okay. Input main arm, input side arm. So this is the input, this is the input. Okay. So we are getting these characteristics. Okay. Fine. So if E plane T is perfectly matched with the aid of a screw turner or inductive or capacitive windows at the junction, how many components we are going to get? S11, S22 and S33 are 0 because there will be no reflection. This is very important. We have to remember that if you completely have a match junction, then S11, S22 and S33 are 0. Okay. Now, when the waves are fed into the side arm, port 3 is a side arm. If I feed the input to port 3, the waves appearing at port 1 and port 2 of the collinear arm will be in the opposite phase and in the same magnitude. So therefore, S13 is equal to minus S23. So it is having a opposite sign because it is a out of phase. Always remember that opposite signs means the both magnitudes are out of phase. Opposite phase में जब भी magnitude होगा we have to write minus. Okay. So this is a S matrix for ET. Okay. S11, S22, S33, 0. Okay. Then if the ports are having a symmetry, so in a symmetry property we can directly use here, which we learn in a signal system. What is the symmetry property? That S12 is equal to S21, S13 is equal to S31, S23 is equal to S32. Or zero property. What is the zero property? The sum of each term of any column row multiplied by the complex conjugate of the corresponding terms of any column row is zero. So we are using here symmetry property and zero property. Okay. So this is the zero property and now your matrix become this. So S13 and S23 complex conjugate is a 0. That is S13 is a 0 or S23 is a 0 or both are 0. When multiplication is going to be 0, either one term is a 0 or both term is a 0. Then and then only this property can satisfy. The answer 0. Now next property is a unitary property. In a unitary property, the sum of products of each term of any one row column multiplied by its complex conjugate is a unitary. Unitary means 1. So this is the S12, sorry, S21, S12, this is a 1. Okay. Then S12 into S12 complex conjugate plus S32, S32 complex conjugate is a 1. Okay. So subset 0 property in unitary property. So this is my answer. So S12 magnitude square is equal to 1 minus S13 magnitude square. Okay. But equation third and fourth are contradictory. So if S13 is a 0, then S23 is a 0. Thus, equation 3 is a false. Similarly, if S23 is a 0, then S13 is a 0, and hence equation fourth is also not true. This inconsistency proves the statement that T junction cannot be matched to the three arms. So this is the proof for this statement. So diagonal elements are not at all zero. Okay. So this is my matrix. When E-plane T is constructed for any empty waveguide, it is poorly matched at the T junction. Hence, Sij is not equal to 0 if I is equal to j. However, since the collinear arm is usually symmetric about the side arm, so S13 complex conjugate, sorry, magnitude of S23 and S11 is equal to S22. So this is a property S11, S11, S33 as it is, S12, S13. This is a S12 symmetry property minus S13 opposite phase. Okay, S13 minus S13. So this is a matrix for E plane T. Now, similarly, can you find out the matrix for H plane T by using the same properties? Okay, so H plane T is also called as a shunt T. H plane T is also called as shunt T. Okay, a waveguide T in which the axis of its side arm is shunting the E field or parallel to H field of the main guide. Okay, so same properties we can use in H plane T. Okay, only one change is there. S13 is equal to S23, and please find the S matrix. This is a homework for you. Now magic T is a combination of a E plane T and H plane T. So collinear arm, E arm, and this is the H arm. Port 1 and port 2 are collinear arm. These are the characteristics. So, characteristics are what? If two waves of equal magnitude and the same phase are fed into port 1 and port 2, the output will be 0 at port 3 and additive at port 4. Okay. Second characteristics, if wave is fed into port 4 H arm, it will be divided equally between port 1 and port 2 of the collinear arm and will not appear at port 3 E arm. If a wave is fed into port 3 arm, it will produce an output of equal magnitude and opposite phase at port 1 and port 2. Output at port 4 is a 0, that is S43, S34 is equal to 0. And fourth property, if a wave is fed into one of the collinear arms at the port 1 or port 2, it will not appear in the other collinear arm at port 2 or port 1 because E arm causes a phase delay while H arm causes the phase advance. So S12 is equal to S21, and this is the S matrix of a magic T. Okay, so now, next 15 minutes, what you are going to do that please complete the S matrix for H plane T. Okay, and from next lecture we will study the applications of magic T. If you are having any doubt, please post the doubt in a Google Classroom. And thanks for attending today's lecture.